I'm a founder of Scalescape. We are building a DevOps platform. I'll share it in detail probably at the end. So I'll also stop my video. So the context here is, I think, like we'll touch on a few things, right? Like one is we'll touch on microservices, we'll touch on a bit on like monoliths, and then like slowly that's what you would have scaled. And then we'll touch on like how we can leverage Kafka or like event-driven systems in order to scale your system like for really large set of customers, right? If there is one thing you need to learn while you're building distributed systems, assume everything is going to fail. It doesn't matter what kind of systems you're building, but be it microservices, monolith, whatever it is, it's going to fail at different points of your system. So in that sense, so let's start with the scenario, right? So I'm not here to like debate whether it's best to start with monolith or microservices. Of course, there are companies which scaled well with monoliths. There are a lot of companies which migrated to microservices and it helped them. But I think like one thing personally, what I've seen is unless you have a tooling and ecosystem built for handling monoliths in a best way, like let's say Google, we all know they're all in monorepo, but they still have good practices in tooling and ecosystem to scale for their customers with a monolith architecture, right? So not necessarily like monolith architecture, like they would have monorepo, but they still have like a different kind of means to deploy and do things. So the assumption is, let's say, hey, if you have a monolith, if you have a failure, the whole system is going to fail. It depends on deployment, of course, but as you adopt microservices, there is a lot of benefits we can sort of benefit from. But even in microservices, of course, there can be bottlenecks, right? So let's say this is just a quick scenario, like you might have multiple instances of the same service. Like this is just zoomed in version of like you might have 500 microservices or like 50 microservices, but on that one particular service, you will have multiple instances. And then like even there, you can have bottlenecks in that systems, right? So then obviously, like as you scale, you will notice like you will move on to like setting up replication or adding in sharding and increasing instances, increasing load balances and everything like that. So let me just see whether you can see the system. So just quickly sharing. I'll stop the whole screen share and then I'll share my whole system. So as you can see here, right, you don't just stop with scaling multiple databases, but you can go ahead and then like introduce country level sharding or other strategies, right? And then you can even go on and expand into like multiple regions within that country. So let's say in this case, I'm just depicting, hey, US, you have more scale, but Canada, you have less scale. So you have a single region here, but you have the same setup, but sort of scaled up to handle the load accordingly, right? So that's just the context. So having said all of this, in order to evaluate and also like figure out whether something is working for you, usually you need to have a checklist of things where this is what you compare with respect to like, be it microservices, be it monoliths, and then even event-driven systems to say whether this system is working well for you or not. So let's say like most of the benefits we get from microservices, even in my personal experiences, so you can scale different systems independently. So let's say in this case, assume it's a different service. You can just scale up the service one for multiple instances rather than you scaling the hardware or like rather than you having to do vertical scaling for the whole monolith, right? So if you have a database, then again, the same thing, right? Like unless you have multiple services and then the data is split across different databases, like you're going to end up with a single database. So that's what I mean by scaling independently, right? The same thing, like when you do a deployment, unless you have ecosystem, when you deploy monolith, most of the times it's like, hey, you see a small downtime, right? Of course, like there are exceptions, right? Like you can do red-green deployment, blue-green deployments and all of that. But if you have microservices, if your changes are limited to, let's say, service one, you only deploy service one, and most of the other systems are not affected by it, right? Let's say blast radius. Like, of course, this is something like specific to microservices as well, but the context is if something fails with respect to your whole system, how much the failure is cascaded, right? Like, hey, do you see a whole system downtime, or like, is it like a partial downtime? For example, if you're using a ride-hailing app, if the promotion is not working, it's fine. Like, but if your whole system is down, and then if you can't board cabs, or if you can't pay, it's super critical issue, right? So even if you're using microservices, of course, you need to have good practices in place to control the blast radius. Of course, like choice of stack, like the time taken to do whatever the set of tasks, like from dev time to, let's say, deployment time, ownership, domain, and all of that. You should have this variables or factors listed down, and then you should discuss on this particular points in order to figure out like whether monolith or microservices, or like how you're evolving over time. So having said that, like I think like most of the cases you would think your microservices is good enough for your organization, right? But let's take this scenario, right? Like I'm just taking the domain of let's say Uber, or like any ride hailing or food delivery services. You will ride, like you will book a cab, you will get a driver, you will have to do payments, you might have some promotion and stuff like that. So in that context, this is just like a small random representation of that particular domain. Let's say in order to complete my order, you might be calling 5, 6 different services, or like even you will end up building a backend for front end. The dependency, or like the mesh sort of structure evolves over time, right? So in that sense, even though whatever like advantages I was mentioning like a bit back, it becomes a bottleneck over time. Of course, like how do you figure out bottleneck? Like all of that, like probably we'll discuss at the end of the event. But I'm just giving you a picture of like, even if you scale with microservices, after deploying and scaling independently, and then you building a structure around it, the closely knitted microservices architecture can bring up an issue. Let's say, for instance, like your order service is critical, but assuming the same instance where promotion service is down, you shouldn't fail the whole request, right? You should ideally have a system in place where, hey, my promotion is not applied, but we can recredit it. But in this case, it's not possible. And then let's also take an instance where the system is just slow, right? A single service, like a latency increase, like the performance degradation, can affect your whole system, because pretty much every microservice will look like it's talking to each other unless you have defined a right boundary, right? So the point here is, when you have a number of microservices growing beyond a point, that's when like we see people talking about it's too much microservices. The microservices is not working well for us. We are like, some companies actually have reverted back to monolith. It's just that like they adopted better practice because now they know what is needed. But yeah, like you see all this transition, right? Like monoliths to microservices, microservices back to monoliths and all of that. But now think about how do we evolve this system without doing that drastic migration, but still like fixing the problem, but still scaling beyond the same factors we talked about, right? So now that's where Kafka or event-driven systems comes into play. So let's talk about quickly about the details a bit, like before going into the architecture. So Kafka is like just like any other PubSub system. If you've used Google PubSub, RabbitMQ, or like any other like queuing mechanisms, it's similar to that, but it's slightly like more evolved in a way that like internally it helps in a lot of aspects in like producing side, consuming side, and also scale, right? Like it's built in LinkedIn. It's massively used in so many high scale companies now. So now, like we'll quickly touch on the key terms, right? So in this case, like I have a bunch of services. I have a customer service, I have a driver service, and then like let's say I have a payment service. Rather than the microservices talking to each other, like you send messages to a queue. In this case, like it's called topics. And then the downstream like services, they consume from that topic and then they operate on it. So the producer in this case is a customer service as well as driver service. The consumer in this case is a payment service. And what they produce, or the queue of, like in this case, it's topic, is basically like the topic. And then in this case, like we have offsets and partitions, like we'll talk about it like a bit later. And consumer group is basically a group of consumers. Like let's say, hey, if you have 3 services and all of them are getting payment requests as a jobs, like a job in the queue, and then you shouldn't be reprocessing the payment again, right? Like ideally, even though you have 3 services, you should be distributing the messages like evenly across, or like you shouldn't send message 1 to service 1 as well as service 2, right? Like when I say servers, it's like instances in this case. So that is the consumer group. So I mean, this is probably a bit detailed, but I'll probably show it in a while. The same thing, right? Like this is what I was saying. Like in internally Kafka, there is a concept called like topics and partition. Each topic is again split into multiple partition. It just helps with scaling. If you have 100 partitions, you can have 100 consumers running for it. So let's say, I'll give you an example. If you have 10,000 messages per second, if you have 1 partition, there can be only one consumer which is consuming at 10,000 messages per second. But if you have 10 partitions, it's almost as if like you can send each partition like 1K requests per second. And then all of your consumers in the consumer group just needs to handle like 1K requests. It doesn't have to handle like 10K, right? But as a whole, you are handling 10K requests per second with this architecture. So now you can extrapolate, right? Like if you have 100K messages per second in the queue, you can handle it with like 20 partitions or 50 partitions and stuff like that. Of course, like there is a lot of discussion and nitty-gritty details around how many partitions you have in a topic, how many consumers works best for your use case and all of that. But like high level, this is the like detail, right? I'm just going to quickly show you what it looks like. I hope my screen is visible, like my terminal is. So let me know if it's not visible. So here I have a local Kafka cluster running. And then we just talk about 3 terms, right? Here I'm actually running a consumer. So I'll just show you console consumer. Ignore the details, but like the point is I am running consumer to my Kafka. And then as you can see, it's consuming messages, right? So here I have a small tool which just sends messages and then like it produces data to the topic. So I'm just gonna send it again. So I'm just gonna probably change the total number of messages. So let's say, like ignore the details, like I'll come to this later on. So yeah. So now as you can see, like the messages are produced here, and then it's consuming in this place, right? So here it's 1 consumer, but we can go to end producer and consumer. Like for each topic, there can be multiple producer. A single consumer can consume from like multiple topics and all of that. So here it's the same thing, right? Let's say, as you can see here, I have 2 consumers. Like this is 1 consumer, this is another consumer. Like I have a watch which keeps on sending data to the terminal. Yeah, like, so let me just receive it. So as you can see, I have a watch, and then it's just sending data to the topic. And then this just receives the timestamp data, like that's what it's visible. So it takes time, but that's the idea, right? Like you have a data which is sending, and then it just receives it over time. As you can see here, it just received the message, right? That's just an example. So now we'll go back to the earlier instance, right? So here, as you can see, like it started consuming. Every second I'm pushing data. There are multiple consumers, so that's why it's slow and stuff like that. But that's the idea. Like you can have a lot of consumers, you can have a lot of data and stuff like that. So I'll also show you like probably the details a bit, but it might So this is what it's just slightly in a different view of whatever we discussed. So this is the topics we have. When we push data, like this is what is being sent. As you can see here, like the data is being pushed. And then like I was running some consumers, right? So let's say I just go and run consumer new one. And then it's going to register here in some time. So yeah. Yeah, I'm just going to check this. So you can see, right? Like I just registered a consumer and it's available. Like I just have a tool to show the data. So now you have topics. Now you have consumers. Broker is actually Kafka cluster details, but we don't see the producer here. But let's just go to the messages, right? Like that's what we were talking about. So here I have messages in this place, and then here you can see, right? I have multiple partitions. This is what I meant by multiple queues over time. So now we have established the terminologies, right? I'll just quickly see the questions. If there is anything like which is blocking, I'll answer it. If not, I'll probably take it at the end. Yeah, so the consumer group, we are running same consumer, not different consumer. Like I'll just clarify, right? So if you want 10 messages, like if let's say you have a top, like in this, let's just go here. I have a topic here. There is so much data, but let's say if there is 10 messages, if you want to receive the 10 messages in two services, you will have two different consumer groups. One called, let's say, payment service. The other one, it could be called, like, let's say, a revenue aggregation service. And both of them will be receiving 10 messages. But in order to scale, like within that consumer group, you can either run 2 consumer instances or you can run like 5 consumer instances within that consumer group. It is purely for scaling purposes, but as a whole, this whole set of instances, it could be like applications or like a binaries, but it's it could be consuming from like the same topic. Like, of course, we'll leave the rejects, multiple topics and all of that, but that way you're saying, hey, I don't want these 2 instances to process the same messages. That's the only difference, nothing else. So now let's go back here, right? Like the architecture we talked about is you have a microservices architecture. It's too tightly knit. I can't scale. Like now, even though we talked about, let's say, hey, initially we talked about our services are independently like deployable. I don't affect other services. But now if you touch on this promotion service, you are affecting the whole system. So now how do we fix that, right? So let's just quickly go here. Like I'll come to the production readiness. How do we figure out bottlenecks? How do we avoid certain things at later end? But in this case, basically, like even though you have built like a microservices or like you have adopted different systems, you have some hacks in place, or like you don't have the best like practices in place, because of which you are facing a bottleneck. Like, I mean, purely you can't handle more messages, or like your processing time is too slow, those factors, right? But like this is where you can take a stance and say that, you know what, I will have to reevaluate the architecture and then like use systems like, let's say, Kafka or PubSub in order to adopt a better scale, right? So the same thing, like slightly dumbed down version of like this, like it becomes tightly knit. But now, rather than you going to like every service calling each other, like in earlier case, payment service ended up calling promotion, you call driver service and everything. But in reality, like, I don't know whether you've noticed, in some systems, you can do the payment after the order is processed, completed, or you can give the credit back via promotion, like after 5 minutes or even after a day, right? Those things doesn't have to be tied together in the actual CRUD flow, right? Like critical transactions flow. So now this architecture is like clear, right? Hey, I have an order as a main entity, like in this case, event. Whenever something changes with respect to an order, I push that into my PubSub system. Here we talk about Kafka, but like again, it could be anything. Now the state of change is being like listened from different consumers. and then they act on it. So for instance, if I create an order, the moment I create an order, like the driver service sees it, it alerts the driver, and then it says, hey, go pick up that customer. But let's say the payment service, on the other hand, like is looking at the same orders. Once the order is completed, then it just pays drivers. If it's canceled, it doesn't pay. Now, the benefit of this architecture is you're not only scaling in with respect to performance and the need of like customers high scale, but it also lets you scale in terms of domain and your business, right? Like it could be promotion service, or it could be, hey, the moment a customer does like 100 orders, give them a fancy promotion. Like you don't have to keep calling that and like calling that like logic in every order creation flow, right? Like that's what you would have ended up like otherwise if you haven't had this architecture. But now this separate service can listen to all the orders and give a promotion if you reach the 100th order. Or it could be like we can create a new service to say, hey, every day, how many orders you made for a driver, or in a month, this is how much you have made like over time. This is how much you made as a tip. Like all of this aggregation can be done in a separate service, and it doesn't have to be tightly knit with the services. So as you could notice, I also represent a database here, right? In the earlier case, you would be calling other data, like other service in order to fetch any kind of detail there. But now with this architecture, we don't necessarily have to depend on the actual source of truth or service. Like you can clone some set of details, right? So that way, like you're just making it faster. So when you're aggregating drivers revenue per week, you can keep a driver ID key in your Redis or like in your database. So that way, not only you are like simplifying the process, but you're also like not depending on like other services. So it's again, there is a good balance of like cloning data. Like you shouldn't be cloning the complete data. But what I'm trying to say is, with the right architecture, you shouldn't create so much interdependency between other services. Let's say a payment service shouldn't be calling drivers again. Ideally, you should be sending events back to PubSub and then listening to that. So the whole data and like what you listen to is events. That's what you will be listening. So whenever you, let's say, have a need to call a different service, just evaluate whether, hey, is this something only I need? Is this something like, is it okay to receive via events? Will there be other teams and other future services who's going to need this data? Then like put it in a queuing system, like a PubSub thing, right? So the only biggest factor is it's going to be eventually consistent system. There is a lot of things like your systems have to be idempotent. You can't assume ordering and stuff like that. Because like whenever there is a distributed architecture, you can as well like retry when there is failures. So in that sense, your consumers have to be idempotent in a way that like it's possible that like you're receiving the same message for payment processing twice, but you have to handle it appropriately. So now quickly go into like some details on like what you need to have in place to like deal with issues, right? It is applicable for microservices or distributed systems, but the ideal case is you need to have like a production readiness checklist, and then go through all of that in order to have the like a good well-established system, like reliable system. For instance, if you have too many microservices, you should have a sensible timeout for like each and every API. You should always say, hey, if there is any request which is taking more than like, let's say 50 ms or 100 ms, I'm going to consider it as a failure. You shouldn't wait for like seconds or like 5 seconds for that service to respond back to you. Retries, right? Assume it's going to fail. Like this is what I was mentioning. Like assume it's going to like the system can fail while producing. It can fail while consuming. It can fail while writing to a database. It can happen at any point in your whole system, right? So in order to deal with the failures, you need to have a retries. And then the moment you have retries, you need to have idempotency in place, right? Of course, like testing, but I think like backward compatibility is an interesting topic, right? Like let's say in an earlier case, you were able to revert back data, like because you have a single database or like you have a schema. But in this case, how do you revert, right? There is no reverts in a simple sense, but you need to send events to trigger the reverts. But of course, there is a lot of gotchas here, right? Like all of them are listening to your pub sub. Like now this pub sub becomes a core central piece of your architecture. You can't afford to have like performance degradation here. Or let's say if somebody pushes a message which is out of contract, then you'll be stuck. So in order to deal with that, like you need to ignore messages which is not falling into a particular contract. You should have a dead letter queue, stuff like, hey, if you try to process 10 messages for like 20 times, and if it doesn't work, I will deal with this message later on and then move on to other messages, right? Because consider this as a stream of events. Like every second you have some request and message coming in. You don't want to wait like on a single message, and because of which you will be stuck on all other messages, right? There is a lag. So there is a concept called lag here. Like probably I can show it later. Those are some stuff, right? Like, of course, like there's something called Hystrix, which tells about like circuit breakers and microservices. But in this scenario, like the biggest thing I would say is you cannot go without having observability in place, because the moment you have so many pieces coming in, how do you know where it failed or like where the latency is increased, where the message is lost? Like you need to have tracing in place. Then like, let's say load testing, right? That's something super critical, right? Like I'll probably go here. So imagine you have a service, and then like in order to know what is the bottleneck, like this is what we will be doing, right? Hey, my expectation for this service, like so-called like customer service, is 50K requests per second. But in order to be safe for 6 months, I will be doing a load testing of like 500K requests per second, and then monitor everything, and then see where the bottleneck is, and then like fix the issues, something like that, right? So this is needed. And stuff like you need to leverage so many different kind of components as well, right? So we talked about scaling your architecture with event-driven system, but as I was showing earlier in like architecture with regions, you need to adopt so many other conceptual like things to improve your performance or scale your systems as well, right? So replication is, rather than you having a single database, like that will become a failure. You replicate and then have a different database. You can shard, right? So in this case, sharding could be as any customer who has a lat long which falls into Canada region, it goes into this Canada servicing architecture. Any service which has a lat long and user region goes into these. And then within these two, how do you shard, right? It could be a simple mod, or it could be like a user ID mod 2, or it could be some other factors through which you decide which particular shard to go in. It's applicable in database. It's also applicable in request, right? Routing with load balancers as well. Of course, load balancer, right? Like as I said, you will have multiple instances, and then you will have a load balancers. Even for load balancers, you will have a load balancers. If that load balancer fails, like it could be because of a single DNS, then you will have multiple DNSs also, stuff like that. So the scaling, like you can, I sort of say it in a funny way, right? Like you're not really solving the problem, but you're just moving the bottleneck from one point to other point. And eventually that particular bottleneck will show up over time. Of course, you need to have metrics in place, right? Like unless you know what is being read, what is being written at a particular point, you can't really do any debugging. These are really good tools. Like of course, a lot of people leverage Kubernetes because these concepts we talked about, like replicas and scaling, it comes inbuilt, right? So that's why people use Kubernetes. But if you're not in a scale like where you need Kubernetes, I think you're better off without it, because of course, like managing Kubernetes can be a pain point as well. Proxy is a load balancer, Nginx is a load balancer, Google pops up. Chaos testing is an interesting concept. Like I've added a reference from Netflix. Imagine you have 500 microservices, and then all the 500 microservices is running in 5 instances. Each of them is running in like 5 instances. So you will have so many machines, right? The chaos testing is basically, I can randomly plug out a database from the network. I will randomly delete VM. I'll randomly stop a service. Then how does your whole business evolves. Of course, like in order to tackle that, like you need to like track that, you need to have testing in place, like continuous testing. Then like I am introducing failure points at different places. And then like you see how the system behaves for it. And then like in order, you need to have like all the rollbacks and then failure handling mechanisms in order to deal with it rather than like whole system catastrophic failure. Of course, observability and stuff like that, right? So having said that, I think the major detail is in terms of event-driven architecture is, again, coming back to this basics, right? You can mess up your architecture if you haven't defined the right boundaries. And then if you don't send small kind of events, like rather than calling orders, what if you create an event and then say, every payment, every order, every details change in your system. If you push it in the same queue, then you can't scale it, right? So of course, you need to have good boundaries defined, good microservices established, good domain in terms of team, not only team, like what services makes a boundary, like, hey, for this service, we'll send this particular event. Even though I have multiple services, order makes sense, payments, events make sense. Does it make sense to like have a, let's say, location event? Like unless you really need it, like don't like exaggerate and then like put everything in place because it's hard to downscale, right? That's the issue. So yeah, again, I think like I can go into details of Kafka producer and consumer, but probably I'll stop here. I'll take questions and then I'll probably come back to the details if there is anything. Yeah, I'm just looking at a bunch of questions. So essentially creating more than which UI. I can share the tool, like it's just called Kafka UI.
Yeah, let me read out the questions because yeah, for the webinar replay, especially people won't be able to see them. But do you want to like, did you finish, right? We can start with the Q&A.
Yeah.
Okay, cool. So the first question, you already answered that. Creating more than one funnel so that it can take on easier flow and mitigate any overload. I guess this is referring to something you were showing.
So I'm going to assume the funnel is this in terms of queuing. And I still need more context. I think this is a bit high-level question. The overload is, and I mean, yes. So to an extent, let's say you can have a topic, and within the topic, like imagine like it's a funnel of like multiple topics, and within that topic you can have 10 partitions or you can have like 50 partitions, right? So the partitions is a very critical thing for like having n number of consumers. You can't run 100 parallel instances if you have one partition, right? Because you only have one stream of data, like it doesn't automatically do it. Kafka handles everything with partitions. So in this case, like I'll just quickly go here. I have one topic which has 3 partitions, but I have one topic which has 10 partitions, right? So not only you have multiple topics, but within each topic, you can imagine it's an index of arrays of data and stuff like that, sequence data within each, like it's a queue and then multiple queue within a queue, like to topic, right? So you can assume in that way. So in order to scale it, you would have to scale the number of partitions here. So let's say like there are means to increase partitions. So like I can basically say we have a data of console data, right? So I'm just going to go to console data. You see the partitions is 2. I can actually say the partitions is 20. And then in some time, like it's going to increase the number of partitions to 20 here. It's all with funneling, right? So that's pretty much it. So yeah, so you can see, right, like the console data is 20. So now you can't, like you can go beyond running 2 consumers, but you can run 20 consumers. So that's the context. But again, like it's very specific details, like happy to sort of share in detail later on. So yeah.
Yeah, if you want to reach out on Platform Engineering Slack channel, Dinesh is there. Another question is, which UI are you using for Kafka?
So I'm actually running Provector's Labs Kafka UI. but there are multiple Kafka UIs which is available. Like long back, there was something called Kafka Manager by LinkedIn. It's a very old date like UI, but it gives data. I personally love Burrow. There is a tool called Burrow, and then I'll find it and then share it. I'll share the list of tools, right? That tool gives you the same kind of UI or data in terms of like how many consumers you have. Each consumer, for instance, like where does it stand? Like, have you consumed all the data? Like, is there a lag and all of that, right? So there are multiple tools, but yeah, I use one. Like I just picked one for like demo purposes, nothing else. Yeah. Cool.
We'll share the list of tools tomorrow with the follow-up. Thank you.
Yeah.
What does the empty state mean in the UI?
I don't know what the like which one is a like if you have any specific thing you can shoot, but I don't know what you mean by empty state here. Chat for more clarification, or like I'll happy to answer like offline.
Yeah, maybe screenshot what you meant. And you'll also share the webinar recording tomorrow, or you can find it on the YouTube. Let me just drop in the link over here real quick.
Yeah. So I can take the next question. Like, how is Kafka different from Redis, right? So Redis is basically very, very different. Like it's a caching storage. So in this case, assume like a database is actually external VM or like external machine which has the data store. For instance, every request you are checking user ID for a particular user, right? Like for be it login, be it payment processing, be it anything, like you need a particular metadata associated with a particular user. You don't have to go to a database, but rather you cache some data. Like once I log in, I can say, hey, you know what? For this user with this email, this is the user metadata. And then like I can go and read that Redis, which is actually going to take like microseconds or like nanoseconds, then like going into database, which takes milliseconds. It's purely for caching. It's key value storages. So I think I just realized my like text is too slow, but anyways. So as you can see, like I have a bunch of keys, and then like there is a key, and then there's just a value. There's nothing else. But in terms of event-driven system, it's a storage mechanism, but you send in data and producers, like you can have multiple producers sending into the same queue, and then you can have multiple consumers consuming from the same queue. Not only that, I can say, hey, I have bike orders, I have like car orders, I have different orders. I can say, hey, consume all orders, like star orders. So there is a lot of benefits with it. And then like it also has multiple details, right? Like let's say when you consume it, and then if something is not received, the Kafka actually knows where you are at. So if there is a stream of messages, and then if you stopped at 50-second message, when you restart the consumer, it's going to send you the 50-second message again. So, but in terms of Redis, it's just a lookup mechanism, nothing else. But yeah, cool.
Cool. Is there a limit to partition number based on broker number for a topic?
So that's a good question, right? So there is no limits. I think like you can go beyond 200, 500 and all of that. I don't know whether there is a limit. Maybe there is, like I haven't looked at it. But the point is you don't need that much partitions. Like ideally, like we took, like my team, we were managing the Kafka cluster for really large scale, but we took a stance saying that at any time you're going beyond 20, 30, probably you have some issue in your consumer. You can't process the message quickly enough. That is why you need me to scale. So prove me that your processing time is fine, then we'll increase it, right? So most of the times, like in my organization, except for one location live things, we had 50 partitions, but everything else, like we were able to do with 12, 24, like mostly 24, 36, like 36 is even higher, is what I would say. The reason is there is a downside to partitions, right? Like if you have so many partitions, like what this means is, like I think like I missed the like I don't have the Kafka architecture in this example, but the Kafka is basically you have 5 brokers, imagine, and all of the brokers need to sync data from each other. And then as you increase, the network latency increases, and then like the Kafka performances can also degrade. So you need to be really cautious. And also the biggest point is if you increase the number of partitions to 100, you can't reduce it to 50. So always go slowly. Only when you hit a bottleneck, when you know that it's not the processing time of consumer, it's the Kafka, like scale it. If not, stick to less numbers. Yeah.
Cool. Could you share a GitHub repo for sample application that has this event-based architecture implemented? So is it something you can share with the
Sure. I have my like GitHub, like pretty much everything. I'll push it to my DevDenu GitHub, or I'll share it later on with you as well. But more than that, I would suggest I usually suggest Byzantine generals problem. This is actually a very interesting concept. Like there is multiple generals who's attacking a particular port. Imagine there is no like communication medium between them. Like how do they synchronize, right? There are some interesting learnings which is exactly mapped to like distributed systems. I can share those things, which just gives you exposure to why distributed systems is super complex. Cap theorem, if you haven't heard about it, like you should definitely read. Like if you need consistency, you can't have like partitions. If you have more partitions, like this is the partitions in a different context, you have more availability, but the moment you have more availability, you are actually trading off consistency. Like if you're using DynamoDB, Cassandra, all this columnar storage, basically they are trading availability for consistency. So Kafka is similar, right? So there are a lot of interesting details around it. But again, like I'll share it. You can look at my bunch of talks and stuff like that probably later on. Yeah.
Cool. How do you track coordination or completeness for a single customer order across different consumer groups?
I don't know, but could you repeat the question? Yeah.
Yeah. How do you track coordination or completeness for a single customer order across different consumer groups?
So I think again, like I would say ignore the different consumer groups, right? Like treat it like if you have a payment service, you have a single consumer group. Within that consumer group, how many instances you are running? Like just abstract it. Hey, it's a consumer. You can have 4 instances processing a particular message, or like 10 instances processing a particular message, but you don't need within the same service, like let's say you're tracking each order and then payment is completed or not, like you're just tracking one by one. You don't need 2 instances, right? So in that way, like a single consumer group will consume all the messages. But if you need a different service, let's say, hey, rather than payment service, you are track, like let's say aggregation service, like end of the day, number of orders tracking, right? It's a different consumer group. So like when I created console consumer, as you can see, like I name it, right? So if I create 10 like terminals with the same name, it is called single consumer group. But if you name it as a different one, it's a different consumer group. So the 10 messages in a topic is going to come to consumer new as well as consumer new one. So I hope that answers it. But like you can go read up on this terms, right? It's like how does partition as well as consumer plays a role together in Kafka? Yeah.
Cool. Next question. So Kafka is not good at handling rollbacks. Do you have any advice or experience with that specific use case?
I don't know what you mean by like Kafka is not good at handling rollbacks, because it's just going to process events. And like there's 2 things, right? If you're using Kafka as a database, it's wrong. Like it's probably wrong. You should be sending data and then like all of the consumers should be consuming within a day. Maybe you can have like 7 days and stuff like that. But when you say rollback, you're actually interested in like making some changes in like the downstream of data, right? Like let's say I created an order and then they paid, but for some reasons, I want to change the order state, or some reasons I want to like delete the credit for a driver, right? So in that case, you would be sending another event into the system, say, hey, recredit or like revert this particular order payment. Then the consumers have to process and handle it. So the rollback is in that case, right? There is a different context to it. Like, let's say, hey, if you fail, and then if your consumer has failed, you can go back and then read last 2 days of messages and then process everything. Like, it's sort of rollback in this scenario, but I don't really agree with like, hey, Kafka is bad for rollback. But again, like, feel free to shoot more context. In terms of domain, your servers have to handle it. In terms of data, you need to resend it and then consume. If the consumer failed in the middle, like Kafka is good at like keeping the data reliably across multiple brokers. So you, like, even if you're not like up for, let's say, 2 hours, you can start from the same place. So I think it should be good. It's really good. Yeah.
Cool. What's your ops stack? Are there any lessons learned?
I'm going to assume like you're mentioning like observability stack. We've used all the market leaders like way back in time, like Datadog, Sentry, like every tool, but like it became expensive for us to an extent. But we started adopting open source tools. So we ended up using Grafana, Influx Stack, and then we like, of course, setting up tracing is hard. So we were using Eager for that. I think the biggest learning, it could be a separate topic, like even I'm building something around that, right? Like in my startup. So the biggest learning I would say is like most of time, like there's two sides, right? Like it's not just logs, pushing logs. There is so many aspects in terms of observability. Hey, APIs, every API you need to track few things. There is something called red metrics. You can go and read like SRE, like Google SRE has it. You can track latency, error rates, and then like a rate. That is a good thing. Pretty much for all API, you need to track it. But more than that, you also need to be sending custom domain metrics. So it's actually nicer to have a alert saying, you know what, usually you handle 100 orders in a minute, but in this last 5 minutes, you don't have any orders at all. So that's a better representation than, let's say, hey, I have 500s. Of course, like 500s is a good representation for us. Like that should be there, but there can be a lot of noise as well. So just like technical metrics, business metrics is equally important. You need to monitor not only your services, you need to monitor infrastructure. You need to monitor like this tracing is not just like with respect to time, right? It's like, hey, if I send a message, if I have 10 components in downstream, who's taking what, like how much time, and then like where it's failed and all of that. So centralized logging is a very different discussion. So there is so many aspects like metrics, dashboard, visualization, and then alerting. Like that is the 3 pillars sort of thing. But again, it's a very different discussion. It's good to have more metrics like for visibility purposes, but alert as you go and do it. Don't do it reactively. I would say that. Like I would say have a production checklist. Whatever is critical, like start monitoring those upfront. Like I would say that is the biggest thing. Like I've seen most of the people think that they can live in live, like go live without observability, but most of the time you're wrong. It's good to have observability. If you go down, then it's there for debugging purposes. If you go live without that, you don't have any visibility at all. So yeah, like start from it from day 0. So yeah.
That it seems that we need another session on Kafka. Dinesh, so many questions and so much discussion. Next question: can you send metadata like JSON through Kafka or only a message string?
So I mean, I haven't dived into detail, right? But this is a Go code. You can ignore it. You can write any kind of contract into the Kafka. You can write JSON and then the consumer can read JSON. In our case, we used to use protobuf because it takes much more less space, like binary encoded. And then we used to have protobuf contracts in the consumers, and then we used to decode it. You can send messages, anything. There is no contract validation per se, like when you're pushing messages. So that's the only catch. That's why I was saying if you push any random thing into it, your consumer should be handling it appropriately. But to your question, you can send JSON, any schemas. There are some schema libraries around it. Yeah, you can push anything, but you can't revert back, right? Like all of the consumers should be adhering to the contract. You can't have 2 different contracts in the same topic. Like those are all some, of course, gotchas. But yeah, like you can push a schema in Kafka messages.
And I see some people, also VJ says you can even write protobuf. You can just need serialize and deserialize it. Do something.
Yeah. You can write any schema like protobuf, like any other different like schemas which is working for you. You can have a custom schema, like as long as you can encode and decode it. Kafka is just like a store, right? So you can send anything. So yeah.
Cool. And I think that this will be the last question, and we'll take other Q&A in the platform engineering Slack channel, if that's okay with you guys, since we're on time, and I realize that most of you probably need to go back to work. So I will just like post the platform engineering Slack channel once again, and I'll copy all of the questions in there. And tag Danish. So Danish, if you can please answer them today or tomorrow, that would be really great. And last question, what's the common solution pattern to connect REST endpoint to message system like Kafka? I mean, the endpoint receiving the request may not be the same as owner of the right partition.
Okay, so the rest is just like what do you call that? Like it's an API, right? If you have an API, which like all the like different microservices is calling you as an API, internally, you don't have to dump the same JSON. Ideally, you would create a new contract and then push that message to Kafka. With respect to ownership, yes, that's a good point, right? Treat some services as the source of truth. For instance, unless you're pushing an aggregate, nobody should be sending in order creation events, like except the order transaction service, right? Why would a random, like let's say payment service push something to orders? So in that sense, like just similar to how in microservices, how you define, this is my database. Hey, with respect to customers, I go to customer service. Any details with respect to drivers, like I go to driver service. In the same way, the event should be generated from the source of truth, like in this case, the appropriate microservices. Of course, it's possible that like you can have format, like if you have two different order generation or processing services, they can send it to appropriate orders, but you can have a different key combinations. Like you can call it like a bike orders and car orders example for an example, right? But I don't think like a REST is directly mapped to here. Like you can if you want, but ideally, like you do some bunch of operations. The moment it's done, then you send an event. Order is created, or order is updated, order is deleted, order is like picked up, order payment complete, and stuff like that. So yeah, like it's not one-to-one mapping is what I would say. So yeah. Cool.
Well, we're on time, unfortunately, but I promise you guys, I copied all of the questions into platform engineering Slack channel, and I will ask Danish very kindly to go in and answer them all today or tomorrow. So you'll see it there, the platform engineering link. I posted it in the chat. It really seems that Kafka topic resonates a lot, so Danish, we should probably schedule another session with you. But thank you so much for this one. It was very insightful, lots of questions, lots of conversations, and thank you. Hope you have a great rest of the day, everyone, and see you next week.
Yeah. Thanks so much, Maria, for organizing. Of course, like I'm super passionate about Kafka. We've dealt with it like so high scale. Like I've seen so many downtimes, like so much war stories. So I'm happy to share it. Apart from that, like it's just a plug, right? Like I am building on that DevOps space because I have seen that personal pain point over time, but I'm happy to share any learnings, or if you think it's relevant, like we should talk. Feel free to DM me on Twitter or like in platform engineering Slack channels, or like I've also shared much more topics and talks around the same, like building backend systems, Kafka, Golang, and all of that. You can also see that in like my blog and YouTube channels. So yeah, like really happy to be here. Thanks again for hosting. Thanks for your time. Hopefully we'll do another probably advanced talk. Looking forward to see more folks again.
Yeah, let's set it up, definitely. Cool. Thank you so much, guys. Bye. Have a great rest of the day.